Hey Mr. Bledsoe, this is Braydon from your 2B class, and this is my video on the Richter scale. So first question right here, who invented or came up with the Richter scale? This was Charles Richter, which is his last name, in 1935, and he was a professor at Caltech. So what could be used to measure the Richter scale is the size. This is the seismograph, which is what measures it. And what it does is there's a piece of paper running through the seismograph, kind of like on a wheel, and there's a pendulum with ink on it. So whenever this, which is like the actual paper is like kind of sturdy with the ground, so when the ground moves, this doesn't, since it's based off of gravity. So however much it moves is how much this, which is the amplitude right here, which is like a flat view of that, would like move side to side. So what you're looking at is like the Y values, and what they base the stuff from earthquakes off of is the greatest amplitude, and then this is the time progressing throughout the earthquake. So how are logarithms used in the formula? This would be local magnitude, like within the area of your seismograph that's actually getting the reading or the data, with the log base 10a, so that's like what your seismograph gets, minus like a reference somewhere else that gets another reading of the same earthquake, with log base 10a, 0, and then parentheses delta. So let's say we had a 5.0, which is 10 times the amplitude of a 4.0. This releases 31.6 times the energy. And the reason why that's 10 times is because that 1 times 10, because the log base 10, so it's 10 times more. What is the Richter scale? Scale using earthquake waves to measure the amplitude, which is what the seismograph does over there. Our occurrences, well, I mean, they've occurred all over the world, but two that I marked down was one in Pakistan in 1945, which was an 8.0, and one in Peru, which was in 2001, which was an 8.4. Now, the one in Peru is 4 times higher because the 0.4 with the log 10 is times 10. So 0.4 times 10 is 4, so 4 times higher than the one in Pakistan. Now, here's a graph or a chart of this. So we got like 1, 2, 3, all the way, and it can go infinite, but the ones on Earth don't do that. They don't go that high. So we have like 1, not really, not felt. Minor could be 2 through 4. Small is like a 5. Moderate 6. Strong 7, and then from there on it just gets harder. So it's like it's exponentially growing, but it's a log, so it's times 10. So this could be like a 1 times 10 is 10, 2, and it just keeps. So basically what it does is every time the number increases, it kind of adds a 0. So it could be like 1, 10, 100, 1,000, 10,000, and it just keeps growing like that, since it's a logarithm. And that's my video on the Richter scale.